Hello, this talk will be about scaling up your cloud application. My name is Martin Omander and I was born and raised in Sweden. I lived in Silicon Valley for these last 20 years. I've worked at 3 startups as a software engineer, worked at Google for these last 14 years, and I am a cloud developer advocate. That means that I help developers like you and others create awesome applications, build on top of the Google Cloud platform. I have used cloud and serverless since 2007. Actually, before they even talked about serverless computing. This was, you may recall, Google App Engine. The very first serverless product was released in beta in 2007 and then in 2008 as a real product. So what are we going to talk about today? Well, as developers, we're still figuring out this cloud computing thing. We are putting various products together in the laboratory, and sometimes it works out great and sometimes it blows up in our faces. So this talk will be about how to cope when your cloud application grows in size, what I have seen work and not work when your application gets more complex. This could be a cloud application that is a web app or a mobile backend. What this talk will not be about is code or how to tune your application's performance. Plenty of other talks about that. Also, I won't talk anything about how to write that web app, that front end, or that mobile front end app. Does this sound interesting? You're still here. Excellent. Great. Let's dive into the talk. So, this is a man, Marshall McLuhan. People call him the prophet of the information age. He basically predicted everything that would happen on the internet, but he predicted it in the 50s and 60s, before there was an internet. One of the many smart things he said back then was this: the social and educational patterns latent in automation are those of full employment, of self-employment and artistic autonomy. So, artistic autonomy, that is what we want as developers. How do we get that? It's right here, automation. So we need to automate our way to artistic autonomy. And we would do that by automating monitoring, but only in the right way. Not all automation is equal. And we would do that by automate testing, but only in the right way. What do I mean by that? Well, let's start digging into monitoring. So I built an application that had a beautiful dashboard. So users could go in and see the dashboard. Business owners could see various metrics, how they went up and down over time. And everything was great, except when the application started breaking. The application started failing. User experience was very, very slow for users. Response times went up by 10x, which meant that cost went up by 10x. And the dashboard didn't tell us. Because the problem when you build monitoring this way is that monitoring is nice, but you're not really monitoring unless you have automated alerts. That dashboard was nice to have. The alerts are a must to have. So set up those alerts. And if you have time left over after that, then you go and build the nice dashboards. So fortunately, you can do this in Google Cloud and many other cloud products as well. But in the Google Cloud, if you only do one thing, download the Google Cloud mobile app on your phone. Because that one will give your phone and will give an alert to you on your phone, a notification, when there's a new error in the logs that the app hasn't seen before. Now, if you want to do more than that, you can read up on, on the product called Cloud Monitoring. If you use Google Cloud Platform, Cloud Monitoring, you get that for free as part of the service. But if you do nothing else, if you run an application on Google Cloud, install the Google Cloud mobile app. The next item was testing. So you need to automate testing, but in my experience, there's a right way and a wrong way to do this. So my latest cloud application I built didn't have end-to-end tests. So I shipped breaking changes many times. And I had unit tests, but those unit tests didn't cache the errors. Because often what happens is that The unit tests, they just check that the code is right, but then how users use it and how the components are put together, that's what you need end-to-end tests for. And testing is this rabbit hole of infinite depth, right? You can go into testing. I've certainly done it, written tons of test code that didn't really help that much, like the unit tests I was describing. Unit tests are great for some risky code or as you're exploring, but end-to-end tests is where it's at when you're running a cloud application. You want to know if things break for the users. For that, you need that end-to-end automated testing. So here, I actually don't have a product to recommend because I'm still looking for one. I've seen a few promising ones that can do end-to-end testing. I think, though, that it's important to pick one that is robust, meaning that as your application changes, this should not be brittle. You shouldn't have to rewrite all of your end-to-end tests every time something changes on your website or in your mobile app. Also, it should preferably be a no-code web testing tool so that your non-developers can help you set up and run this. Also, from what I've seen, the no-code web testing tools are a little more forgiving and a little more robust, less brittle, won't break whenever you move something a little bit. So find that tool. I'm still looking. If you have a good tip on this one, please let me know. But go find one of these if you run a cloud application. Next, productivity. So again, a man much smarter than me, Franz Kafka, said, productivity is being able to do things that you were never able to do before. So we're talking about real productivity gains here, large productivity gains. They mean that you can do new things, spend your precious developer time on things that you didn't do before because you were just shaving yaks, doing stupid things that made you feel productive, but that kept you busy. So busy isn't the same as productive, and you need to understand and love IAM. Let's dig into that. Busy isn't always the same as productive. So I've read up on VPC, Virtual Private Cloud, recently. I took a lot of courses about it. I started implementing it for a tool for a web application I was working on. But I realized that while it was cool technology and while it would keep me busy for weeks to come to set everything up correctly, it didn't really deliver any value to users. I would have been busy, but not productive. I wasn't bringing any value to users. So, and we see this over and over again, right? I certainly see this when I work with developers. Developers and ops people are often, they know how to solve certain problems, like setting up virtual machines, configuring networks, that sort of thing. We set up and configure your database is another one. You can spend infinite time on these things. But is that really your comparative advantage or your organization's comparative advantage? Managing service, setting up networks? Maybe it is, but I would say for most organizations, this is not the core competency. This is not what will set them apart from the competition, will make them money, or will make the world a better place. No matter how you set up your firewall, no matter how good you are at that, the world won't be a much better place. You should let somebody else do it. And one way of doing it is to go serverless. So on GCP, Google Cloud Platform, there are 3 serverless products for computing: Cloud Functions, Cloud Run, App Engine. I suggest you check those out in that order. If you manage to write your entire cloud application in Cloud Functions, boom, you've eliminated at least 50% of the work of setting up virtual machines. Go check these out. Be productive. Don't just be busy. Next, we had IAM. So IAM stands for, gosh, I don't even know what it stands for, but it is the part of your cloud account that shows what roles there are and what access levels there are and what users there are, who can do what in your account. So recently, I deleted thousands of accounts from the prod database of a web app I was working on, thinking this was the test database. So while that was klutzy and not very smart of me, mistakes do happen. And this is where IAM protects you. Because IAM and this sort of access level control is not it's to protect you against mistakes. Mistakes are far more common than hackers. And we should all do well to remember Hanlon's razor. Never attribute to malice that which is adequately explained by stupidity. This was certainly the case here when I deleted. I mean, the only major problem we've had in this, my web application, my cloud application, has not been hackers. It has been me deleting a bunch of accounts. We should have set up IAM so I wouldn't be able to do this. So study IAM. Get to know it well. There is a great Coursera course about it, IAM on GCP. Check that out. And then set up your environments very deliberately and think through this. You should have one production environment. This is where your users are served. You should have one or a few test environments. Or in the production environment, your developers should probably not be able to read and certainly not be able to write anything. In the test environment, you typically have test data, so it's okay for developers to be able to read, maybe even write some data there. And then you should have one development environment per developer. And developers should have full access and be able to control anything and change configuration settings and everything there. And each of these, the one production environment, the multiple test environments, the multiple dev environments, they correspond to GCP projects. So you have one production project, one or a few test projects, etc. And then you can really scope down IAM so no developer can go in and accidentally delete production data like I did recently. Next, we have 2 ears and 1 tongue so that we would listen more and talk less. Wise words from Diogenes. We should do well to remember this. And this leads us to, we need to listen to users. So there are 3 different ways that I find listening to users have been very beneficial for me when I've been building my cloud applications. The first one is provide a way for users to send feedback to you with 0 friction. Well, we can't hit 0 friction. That would be telepathy. But with as little friction as you can. So I added a feedback form to a web application I built, and this has taken off and gone beyond all expectations. The very first week I put it in, a user reported that one of the features in the application, in the web app, in the front end, didn't work. I thought it worked because it worked on my dev account. Turns out it didn't work for the rest of the world out there. I would never have known if users didn't have a way to tell me easily. So let the user send their feedback to you with minimum friction. Makes them happy and it makes you aware of what they're doing. And also, you can't find all errors anyway, because users, they use your application in different ways and they have different behavior than you think about. Also, you cannot imagine what all the things users want. Your product manager can't either. Your CEO can't either. Listen to users. And you know, one way, a very good way of building products is listen, ask users what they want, provide a first v1.0 product, then ask users what they want, how you can expand it. If 3 or more people say the same feature, you build that, and if you keep doing that month after month, you will get a pretty darn good application very quickly. So you can do this very easily, actually, by setting up a feedback form in Google Forms. And you can capture, actually, when people click on that, you can capture the browser's user agent string in the form. And now all of a sudden, you write a little Google App script to translate those browser strings to real browsers. And now you will know that Bob, who sent in this feedback that sorting doesn't work in the application, you know that he's running Internet Explorer 11, for example. All right. Track all user actions. That's the other way of listening to users. This is truly 0 friction, actually, because here users just have to use your app. They don't have to write anything down, and you know what they're doing. So when I write an app, whenever a new button is added to the code, whenever a new feature is added, I add a Google Analytics event for that. And I found in one application I built that this application has Twitter integration, which I thought was really cool, and it was really challenging technologically building this function, this feature. I loved it. Turns out basically nobody was using it. I should not spend time on that. So you should use this data, this tracking data, to inform your priorities. Some things are cool and sound interesting, like the Twitter integration, but they're not used very much. You can create funnels too. So for example, I've written an app that had Facebook login and Google login and Twitter login. All of a sudden, one day, Facebook login stopped working. And I saw this in the reports right away because there was tracking of, user starts doing Facebook login and then a user succeeds with Facebook login. And when I saw that the conversion rate between those two events dropped and to 0 overnight, I knew something was afoot and could take action. So the action here is to check out Google Analytics if you write web apps. Check out Firebase Crashlytics as well if you're writing mobile apps. And also, you should, so that's the very first part. And then if you want deeper tracking, you should consider products like LogRocket and similar that actually records what the user is doing. You can actually see the mouse moving around. It's pretty cool. And they record stack traces from local JavaScript errors and similar. You need this. Finally, listening to users. Users don't like to give you personally identifiable information, PII, and you may not need it. I had a database with a cloud system that had hundreds of thousands of email addresses in it, of users. That was pretty darn scary. This is PII. Very scary in case there's a data breach. I would have to let all these people know. I could be sued. I might have to take action on all of this. It's scary to sit on PII. So it is a liability. And also the laws are getting more and more strict about this. GDPR, for example, that GDPR compliance is hard to do right. Also you may need a data protection officer. If you have PII in your production database, that may mean that your developers may not be able, you may need to block it so developers can't see the production data. Things just become harder when you have PII. And luckily, nowadays, if you choose a modern single sign-on solution, you may not need PII. For example, Firebase Login. I know a lot about this product because it's a Google product. This one, if you so choose, it can give you, you can get the user's email address, or you can get just a long number that is a unique identifier for them. That number contains no data about them, no email address, nothing about where they live or anything. That number is safely to pass around, safe for your developers to see, and if, heaven forbid, there should be a data breach, attackers can't really do anything with that long number. All right, we're nearing the end of this quick talk here. The last one, I saved this for last. It turns out that a computer lets you make more mistakes faster than any invention in human history, with the possible exceptions of handguns and tequila. So this is not a philosopher said this. I heard this at a party. You remember the before times when we still had parties? Yeah. You need to plan for failure. There will be failures. You can have all the tests you want, but there will be failures. So we need to do three things to plan for these failures. The first one is you need to have backups instead of good intentions. So this happened to me actually. I was taking automated backups, but when there was a problem, when I restored all the backups, these backups didn't work in a way that I understood completely. I had to read up on it. It was a stressful situation where users were waiting for their lost data to come back to them. This was no fun. I sorted it out, but I would have liked to know how this whole thing worked before I had to figure all this out with the angry users beating down my door. And the cycle of backups is that, one, you take backups, But, you know, if you're taking them manually, you're not really taking backups. You need to automate those backups. And okay, I've automated the taking of backups, but you really don't have backups yet. You only have backups when you've tested that recoverability. If you do these three things now, you actually have backups. If you don't do these three things, you just have good intentions. So test these backups. Fortunately, Firestore, Cloud SQL, Spanner, all of these great product databases in Google Cloud that let you, with a few clicks, back up to a cloud storage, so you can have your backup files there. So you should automate that. Every now and then you should restore a backup just to see how it works, know where to click, where to set things up, because at 2 a.m. with angry users calling you, you may not remember. Get to know the system, get to know your backups, and that way, only that way, will you actually have backups rather than just good intentions. Next is code is a liability. And this could be hard for some of us developers to swallow. I mean, I'm an application developer. I measure my productivity in how much code I write. But often more code, actually most of the time more code is not helpful. So I wanted to automate some alerts earlier. So I started designing a system to monitor my Google Analytics account and see if the number of users on my website right now, the real-time API, if that dropped below 0, and then it would send a text message to me. Brilliant. However, it turns out that this could all be done with a few mouse clicks. Not a single line of code was actually needed. I could connect to Google Analytics with this third-party tool called StatsGlitch, and that detected anomalies. And then I could trigger from StatsGlitch, I could trigger a job in Phasier, another third-party tool that sent the SMS text message. Because when we developers write code, on average, that code contains 3 bugs per 100 lines. So this particular feature here, sending alerts if users went below a certain threshold, that would have been, I don't know, 200 lines of code. That means, boom, I would have just saddled myself with 6 bugs. 6 bugs that needed to be fixed, and code that needed to be tested, that's another cost. Code that needed to be maintained for from here to eternity, possibly. And even retiring code is costly because you have to figure out what code you can retire. I was far better off in this case not writing a single line of code. Unfortunately, right now, there are many startups that have surprisingly good services and low prices and that do cool things in the cloud because they're founded by venture capitalists. So you should totally use them. These products that I used, I mean, I set up a free trial. I don't remember if they even cost me something or a few dollars per month maybe. Use these products. Somebody else has written the code. You don't need to write it. Code is a liability. Write as little of it as you can. Next, we have feature flags and canary deployments. This is, I live and die by this. So when I write an app, I usually store as many config values I can in the database, because then I can update the config values, the parameters of my application 10 times a day, 10 times before breakfast even, because the application reads from the database before it does anything. So by doing this, when things break, you can change a flag in a database instead of deploying new code. Because all the tests in the world can't find all the bugs. We talked about that before. And rolling back code, you deploy a new version, it's bad, now you need to roll back. That is surprisingly hard. I mean, it sounds easy, but especially if you have a large team, you've built a factory that delivers code. You have conveyor belts of code going out. And when you say, let's roll back, all of a sudden you're saying that the whole factory, you have to reverse all these conveyor belts. That is hard. Instead, when you deploy a new feature, do a canary deployment. This is where you send it out to 1% of users, 5% of users, 10% of users, and you can easily turn that knob down without a new deployment if it doesn't work out. And feature flags. a major new feature is deployed, put it behind a flag that you can change without deploying code. So fortunately, there are products that do this for you. For example, if you run serverlessly on Google Cloud, Cloud Run lets you split traffic by percent across multiple versions of your app. So you have all the versions lined up, you have a long list of all the versions you built. You can say, 1% to this one, 99% to this one, change it as often as you want. If you write a mobile app, Firebase actually has a really cool feature that lets you do remote config of mobile apps. So you can say things like the login button should be red, and all users see a red login button. Next day or an hour later, you can change it on your side. It should be blue. Boom, users see a blue one without having to redeploy code. Use this, feature flags, canary deployments, remote config. This makes your world better and less chance of you having to wake up at 2 a.m. and fix something that broke. So with that, please experiment, be mad scientists, create your own great cloud applications for users. You are wizards, dear developers, you're able to do stuff that nobody else can. Be crazy, do cool things, and remember to do these 10 things as you're doing your crazy experimentation, and users will be far happier, you will have more autonomy, everything will be better. Thank you for your time.